All right. Have you ever looked at code and just felt a little overwhelmed? Don't worry, you're not alone. Today, we're going to pull back the curtain on Python, one of the friendliest programming languages out there. We're going to break it all down into simple, easy-to-grasp building blocks.
Okay, let's just dive right in. Take a look at this. Believe it or not, what you're seeing right now, that's it. That's a complete, fully functional Python program. All it does is tell the computer to show "Hello World" on the screen. And that right there is the whole magic of Python. It's built to be straightforward and get things done fast.
But, to go from that one little line to building something truly impressive, well, you need to know the fundamentals. It's kind of like building a house, right? You can't start without knowing what a brick is or what wood is for. Programming is exactly the same. So let's open up the toolkit and see what we've got. First up, every single program, I don't care how big or complicated it is, starts with the absolute basics, raw data. These are your ingredients, your raw materials. But you can't just leave your ingredients lying around, right? You need bowls or containers. In the world of code, we call these containers variables. They're just little labeled boxes for holding our data. So let's check out the 4 main types of raw materials you'll be working with. First, you've got a string. That's just a fancy word for any kind of text. Then there's an integer, which is any whole number, like someone's age. If you need a number with a decimal, like for a price, that's called a float. And maybe the simplest of all is the Boolean. It can only be one of 2 things, true or false. That's it. Seriously, these 4 things are the absolute foundation for almost everything we're going to build. Okay, so we've got our materials, and they're all neatly stored away in our variables. Now what? Well, materials don't just assemble themselves. We need to give the computer instructions, a set of blueprints on what to do with them. This is where the magic really happens. This is how we make our code smart and let it actually make decisions.
And the most fundamental way a program makes a decision is with an if statement. You can literally read this like plain English. If the score is 90 or higher, then print the letter A. It's just a simple test. If the test passes, the code inside runs. If it fails, well, the program just skips it and moves on to the next thing.
Okay, but what happens if the score isn't 90 or above? We need another option, right? That's where elif comes in. It's just short for else if. So now our program has a chain of command. If the first test fails, it doesn't just give up. It moves right along to check the next condition in the list. And to finish off our decision-making blueprint, we have else. Think of else as the safety net, the catch-all. It's what the program does if none of the other conditions, the if or the elifs, were true. So with this whole if-else-else structure, we've created a really powerful way to handle basically any situation we throw at it.
Now, besides making decisions, computers are amazing at repetition. There are 2 main flavors of this in Python. For loops are perfect when you have a specific list of things you want to go through one by one. Like, for each fruit in this basket, do something. You know exactly when it ends. A while loop, on the other hand, is more like, keep doing this thing while some condition is still true. It just keeps going until that condition finally changes.
All right, so we've got our individual variables, our little containers. But what happens when you have, like, 100 of them, or 1,000? It's going to get messy fast. You need a bigger storage system, right? Like a toolbox, or maybe a whole filing cabinet. In Python, we call these data structures, and they're all about organizing and managing big collections of our data.
And the most common kind of go-to storage system you'll use is the list. It's super flexible. You can throw all sorts of different data types in there together. But the really important word here is mutable. All that means is that it's changeable. You can add new stuff, take stuff out, swap items around, whatever you need to do. And this brings us to a really important concept, this idea of being changeable or mutable. We just saw that lists are mutable, but then you have its cousin, the tuple. And a tuple is the exact opposite. It's immutable. Think of it like data that's been set in stone. Once you create a tuple, that's it. You can't change what's inside. And that's actually super useful for things you know shouldn't ever change, like the coordinates for a specific location on a map.
Okay, now this one is really clever. A dictionary. Unlike a list that just keeps things in order, a dictionary stores information in connected pairs. You've got a key, which acts like a label, and a value, which is the actual piece of data. The name is perfect because it works just like a real dictionary. You look up a word, the key, to find its definition, the value. This makes it incredibly fast to find exactly what you're looking for.
So we've got our raw materials, we've got our blueprints for making decisions, and we've got our storage systems to keep everything organized. What's left?
Well, it's time to build our own custom power tools. I mean, why would you want to do the same task by hand over and over again? We can bundle up our instructions into these amazing, reusable blocks called functions and classes. This is what really makes your code efficient and clean.
So let's start with functions. A function is basically a mini program that you can run whenever you want. It's a really simple three-step process. First, you define it. This is where you actually build the tool and tell it what to do. Second, you call it. That's just using the tool by its name. And finally, you use its result. The function does its job and gives you something back that you can use. It's such a simple but powerful way to stop writing the same code again and again.
Okay, ready to level up? If a function is like a single power tool, you can think of a class as the master blueprint for building something really complex. You spend time designing the blueprint once, and then you can use that same blueprint to build as many individual objects from it as you want.
And here's exactly what that looks like. We create a blueprint called class dog. This blueprint says that every dog we create from it will have a name and an age. Then we actually use that blueprint to make a specific individual dog. Here we're creating my dog from the dog blueprint and giving it the name Rex and the age 4. We've just made an object, a unique dog named Rex. And now the cool part is we can use that same blueprint to create a whole pack of different dogs, each with their own name and age.
All right, let's do a super quick recap of our entire toolkit. We started with variables, which are our raw materials, right? The wood, the stone. Then we moved to control flow, which are the blueprints that let our code make decisions. After that, we got organized with data structures, our toolboxes and shelves. And finally, we built our own functions and classes, which are like custom-made power tools to get the job done faster. And that's really it. These are the fundamental building blocks you'll use in every single Python program you ever write.
And that's a wrap. You now have the map, you have the essential tools, you have the raw materials. We went from a single line of code all the way to understanding the blueprints for creating really complex things. The entire foundation is right here. So now, the only real question left is, what are you going to create?